Hello! Our lesson today is an introduction to polynomials. Our goal will be to work on defining the parts of a polynomial, and also to be able to learn how to combine like terms and also add and subtract polynomials together. So that's our goal. Let's get started. We're going to start with definitions here. Before we do anything, we should probably define what a monomial is. A monomial is any number, variable, or any combo of a number and a variable. For example, the number 3, that's considered a monomial. A variable, if we just had x, that's a monomial. We could have a bigger number, 100. We could have a bigger x, x to the 5th. These are all monomials. We can even have when they're both together, like 5x squared. That is also a monomial, or 3y to the 5th. Usually the rule for monomials are that the power has to be positive, so the exponent has to be a positive sign. If we were to say that this is -5, that's not usually what we call a monomial. Okay, good. Let's go ahead and move on. So a polynomial then, poly meaning multiple, is just when we put more monomials together. So for example, x plus 7. X plus 7. Whenever we have 2 or more monomials put together with either a plus or a minus sign, that becomes a polynomial. We could have x to the 5th plus 2x squared minus 11. That is a polynomial. Or 4y plus 13, or 17x squared minus 5x plus 11. These are all polynomials. Okay, so the name terms basically just represents the actual monomial. So terms are the monomials in a polynomial. So if I had x cubed plus 3x squared plus 2x plus 5, this has 4 terms. This is the first term, this is the second term, this is the third term, and this is the fourth term. If I had 4y minus 11, this has 2 terms. This is the first term, this is the second term. We usually like to write polynomials in ascending order, meaning that the terms with the highest power come first. If we had like 5 minus 3x plus 2x squared, that is not ascending order. We usually like to write the highest powers first, so this would come first. This would come second because the power is 1, and then this has no power. So do realize that we usually write polynomials in what is called ascending order, going from, or descending order, going from least to going from greatest to least. Okay, the coefficient. The coefficient is the number of each term. So if I had like 3x squared plus 6x minus 11, this is the first term, and we would call the coefficient of that term, the coefficient is the number. So in this situation, 3 is the coefficient. What's the coefficient of this term? You bet. You should have said 6. 6 is the coefficient. And this is the third term. What's the coefficient of it? Yep. You got it, -11. So remember, coefficients can be negative. So if I had like -2x squared minus 7x plus 11, the coefficient of this is -2, coefficient of this is -7, and the coefficient of this last term is 11. We usually do define another coefficient. We call the leading coefficient. We do have a leading coefficient, and that is the very first number that appears when it's written in order. So when it goes from greatest to least, so when it's in ascending order, the first number with the first term is the leading coefficient. In this situation, 3 is the leading coefficient. And here, -2 is the leading coefficient. Ooh, what would be the leading coefficient of this one? That always kind of tricks people up. Remember, the leading coefficient is the number that goes with the very first term when written in descending order. So the leading coefficient of this polynomial is actually 2 because it's not written in order. Remember, highest powers go first. The leading coefficient of this polynomial would be 1. There's an implied 1 right there. Okay, good. Last thing we want to talk about is the degree. The degree of the term is just the exponent. It's just the exponent. So if I had, for example, 5x to the 7th plus 2x to the 3rd plus x minus 15, we could find the degree of each term. So this is the first term, and the degree would be 7. It's just the highest power. This, here we have the degree of 3, the power associated with that degree. For this term, the degree is 1. And for this last term, the degree is 0 because there are no variables. There are no variables that are associated with the last term. Again, just like we do with coefficients, we have a leading coefficient, and we have basically what's called a leading degree. The leading degree, in other words, that's the degree of the entire polynomial, and that will always be the one that comes first, again, when it's written in order from highest to lowest exponents. And so the leading degree for this polynomial is 7, the degree of the polynomial, because that's the highest degree that exists. Okay, well, we've done some work defining some polynomials. Let's go ahead and write up some example questions that you can do in your video notebook, just to make sure you understand all of the lingo that is associated with polynomials. Okay, so here are 4 questions we'd like you to try. You can go ahead and pause your video notebook, pause the video, and use your video notebook to write your answers down. Make sure that you can identify or understand the definitions here. We want to make sure you understand the words like polynomial and term and leading coefficient and degree. When you're ready to check your answer, go ahead and press play, and we'll go over these. Okay, let's see how you did. We've got this first question says, write the polynomial in descending order. That means highest powers come first. So this has the highest power. So we're going to write 5x to the 9th. The next highest power would be this, so plus 3x squared. The next term with the highest power would be this, plus x, and then last would be plus 3. This is called descending order. It's got 4 terms, and we went from the highest power down. Okay, good. Question number 2, identify the leading coefficient and the degree. So the leading coefficient is the number in the very first term when they're put in order. So we should check to make sure these are in order. 3, 2, 1, 0. Okay, good. So we're all right. This is in order. So the leading coefficient, I'll call it the LC, equals 7. And the degree of this polynomial will be the highest power, which in this case would be 3. So it is a degree 3 polynomial. Okay, good. On this question here, it says, how many terms does a polynomial have? This has 1, 2, 3, 4, 5 terms. It has 5 terms. And just to let you know, sometimes we do name polynomials by how many terms they have. For example, monomial. If it was just 5x, that is a monomial. If it's 5x plus 1, that is a binomial. If it is 5x squared plus x minus 3, notice this has 3 terms, so it's called a trinomial. So based on the number of terms, this has 1 term, monomial, 2 terms, binomial, 3 terms, trinomial. Anything above that, we just call it a polynomial. So this one here, 5 terms, that's just a poly. We don't have special names after anything above trinomial. Okay, good. Question number 4. Identify the leading coefficient and degree. Now, this one's a little tricky because it's got to be in order. So when I look at this, I've got power 3, power 4. That's not in order. So the first thing I'm going to do is write this in descending order. 4x to the 4th plus 2x cubed minus x squared plus 2x plus 9. That is now in order. 4, 3, 2, 1, 0. Okay, good. So now we can identify the leading coefficient. The leading coefficient is always the number associated with the highest powered term. So the leading coefficient, the LC, is negative 4. And the degree of this polynomial is the highest power, which is 4. Okay, great. So that's the first part of polynomials. The next thing we need to do is make sure we know how to add polynomials, which is actually pretty easy because it's all about just collecting like terms. Let's go ahead and take a look. So this part of the lesson should not be anything new. We know already about like terms. For example, if I have 5x plus 3x, well, that comes out to be 8x. We know that we can combine x's with x's, or I can combine smileys with smileys. Get 8 smileys. And we can combine winky men with 3 winky men. So 2 winky plus 3 winky is 5 winky. We know this. We know this is the rule. However, sometimes we fall apart because sometimes there's things in math that are wearing hats. Oh gosh, hats. Now listen, hats are nothing to be scared of. If I've got 5 guys wearing a top hat, looks like Abe Lincoln, plus 2 guys wearing a top hat, what do we get? You know, 7 guys wearing a top hat. Hats do not change anything, okay? Hats do not change anything. For example, what if I had this? 3 guys wearing, this guy's wearing a ball cap. Doesn't really look like a ball cap. Plus 7 guys wearing a top hat. What do we get? We can't do it. Remember, they've got to be the exact same. They've got to wear the exact same hats, or you cannot combine them. Okay, they've got to be exactly the same. Now, in math, hats are usually exponents. Okay, if I've got 5x squared plus 2x squared, notice the x's. They're wearing hats. And are these hats the same? You bet. So therefore, we can combine the like terms. We get 7x squared. The hats don't change. Sometimes people are like, oh, I've got 2 hats, and so they're going to put 2 hats, or they do something weird. I don't know. But if you've got like variables that are wearing the same hats, and you add them together, it's the same. 3 apples plus 2 apples. Apples are the same, so we get 5 apples. Again, when we combine like terms, things you can add and subtract things as long as they are exactly the same. Okay, so can I combine 3x squared plus 5x cubed? No! They're wearing different hats. You cannot combine those. So just remember, when we're doing polynomials, when we're combining like terms, you're going to add the things that are exactly the like. And if they're not alike, then you just leave it the way it is. Let's take a look at an example. So here's an example of adding 2 polynomials together. Here's our first polynomial. It has 4 terms. 1, 2, 3, 4. Here's our second polynomial with 3 terms. Okay. Again, when you add polynomials, all you simply have to do is combine the like terms. So I'm going to combine all my like terms. Remember, like terms have to have same hats. So here I have 3x cubed, and here's 4x cubed. They have the same hats, so we can combine them. 3 of these guys plus 4 of those guys comes out to be 7 of those guys. Okay? 5x squared. 5x squareds have to be combined with another x squared. Ooh, over here there's no x squared. So there's nothing to add to it. So we're just going to write it here. It's 5x squared. It doesn't change at all. Here we have 1x plus 2x. 1x plus 2x is 3x. And then combine our numbers. We get 3 minus 5, which is 2. So our final answer there is 7x cubed plus 5x squared plus 3x. That's how we add polynomials together. Just combine the like terms. Let's give you guys some practice problems. Take out your video notebook and give these a try. Okay, here are 3 problems we'd like you to do. We're just adding polynomials, so you just combine the like terms. Go ahead and pause the video, try these 3 questions in your video notebook, and then push the play button to see how you did. Okay, let's take a look. We've got to combine the like terms. That's our goal here. So I've got 3x to the 5th. The hat is 5, so we would have to combine it to something the exact same. Here we go. So I've got 3 plus 2. That's 5x to the 5th. Here I've got minus 7x, and this is minus 4x. Those are the same hats, so we can add those. Minus 11x. And we got plus 3 minus 11. That comes out to be minus 8. Okay, great. On this next one, things aren't written in order. Maybe you wrote them in order. That's fine. I'm going to just go ahead and look for hats. I've got x to the 4th. I don't see any other, so I'm just going to write that down. X to the 4th. Now let's look for x cubes. I don't see any other x cubes except that one, so let's go ahead and write that down. X cubed. Now let's do the squareds. 3x squared plus 5x squared comes out to be 8x squared. Cool. Now let's just do the x's. There's only just one x, so we're just going to write x. And then we do have some numbers. 1 plus 2 comes out to be plus 3. So again, if something doesn't match up, it's not a big deal. It just doesn't add to anything. And so we just write it. Last one here, combining like terms. We have an x squared plus an x squared. That's, again, there's an implied 1 here. So 1x squared plus 1x squared is 2x squareds. And then we add the numbers plus 8. Okay, that's how we do it. Let's take a look at subtraction. I quickly want to review one thing, and that is back in Chapter 2, we talked about how whenever you have a number outside the parentheses that's being multiplied to the parentheses, you can take that number in as long as you multiply it to everything that's inside the parentheses. So this 2, for example, would go to the x squared, which would get us 2x squared. The 2 would also go to the 3, which gets us plus 6x. And this 2 would also go to this minus 5, which would get us negative 10. Please note that the same would apply whenever you just have a negative out front. This is an implied negative 1. So this negative would go inside and get us negative 2x squared. The negative would go inside here and get us minus x. And the negative would go inside here and get us plus 7. Just the signs just change. That's all that happens. Same here. We would get minus 3. The sign would change here. It would become plus x squared. And then the sign would change here as well, giving us plus 7x to the 4th. If we think of negatives this way, this will really help as we start subtraction. Because for all subtraction problems, when we do polynomials, it helps to distribute the negative. Let me show you an example. Okay, so let's say we're subtracting some polynomials. I would encourage you, every time you subtract polynomials, to turn this problem into an addition problem simply by distributing this negative through the parentheses. So if we did that, I'd have 5x cubed plus 2x squared minus 3x plus 7. And then as we distribute the negative in, we get minus 3x cubed minus 8x squared minus x plus 10. Now this entire problem has the negative distributed through it, and now we can combine like terms. So we've got 5x cubed minus 3x cubed. 5 minus 3 is 2x cubed. They're wearing the same hat, so we can combine them. Here we have 2x squared minus 8x squared, which would leave us with a negative 6x squared. Now let's do the x's. Here we have a minus 3x minus 1 more x. That's negative 4x. And lastly, plus 7 and plus 10, plus 17. And so this is the answer we get when subtracting these polynomials. Again, I'd highly recommend to distribute that subtraction sign. Distribute the subtraction sign and then combine like terms. Okay, great. Let's give you guys some problems to try, and to the boards! Okay, so here are your 3 problems. Go ahead and pause the video and give these subtraction problems a try, and then press the play button to check your answer. Okay, here we go. First thing I would do, and I would recommend everyone to do, is distribute that negative. It's just too not worth it. So I'm going to go ahead. We get 4x squared minus 2x plus 3. I'm going to take that negative, distribute it to here. So minus 7x squared. The negative to here, minus x. And the negative to here, which would make it plus 11. I then combine the like terms. X squareds with x squareds. 4 minus 7, that's negative 3x squared. Negative 2 minus x, that's negative 3x. And 3 plus 11 is 14. Okay, good. Again, distribute the negative here. X squared plus 9 minus x squared plus 9. So x squared minus x squared, those cancel out. 9 plus 9, you just get 18 on that one. Kind of interesting. Here we get x to the 4th plus 3x squared plus x. We distribute the negative, so negative x cubed minus x squared. The minus minus becomes plus 5x minus 1. Then we can combine our like terms. X to the 4th, there's nothing else. Nobody else is wearing a 4 hat, so we just write that. X cubed, here's an x cubed. No other x cubes though, so we'll just write that in, minus x cubed. x squared. So 3x squared minus x squared. So 3 minus 1, that's 2x squared. Here we have a plus x and a plus 5x. That's plus 6x. And lastly, a minus 1. So that is the answer for the third one. Okay, so here are two questions for you to try. Again, you're just adding, in this number 1, you're going to add the polynomials together. In number 2, you're going to subtract the polynomials. So go ahead and combine. Again, we just combine like terms on these. Go ahead and pause your video and check your answer by pushing the play button. Okay, how'd you do? Let's find out. Again, this is just like our previous section, so we're not going to do as many practice problems because it's pretty much kind of redundant. We're just combining like terms here. So I've got 2x, I've got x squared. Are there any other x squareds? No. Oh, here's an x squared. Sweet. So 2x squared, 3x squared comes out to be 5x squared. Now I'm looking for some xy's. Any other xy's? No. Ah, here's some xy's. So I have negative 1xy minus 7 more xy's. So negative 1 minus 7, that comes about to be negative 8xy's. Okay, sweet. Now y squareds. Combine my y squareds. Y squareds. Ah, here's a y squared. So we have plus 1y squared minus 1y squared. Ooh, those cancel out. And so this is my final answer. 5x squared minus 8xy. We just combined the like terms. On this next one, it may help. Remember, when we subtract polynomials, we said that it's really good to distribute the negative. So I think I'm going to go ahead and do that. I'm going to switch this minus to a plus and distribute that negative into each of the terms. So this becomes minus 2ab. This becomes minus 3a squared b. And this becomes minus 5a cubed. It's really nice to make subtraction problems, addition problems, simply by distributing the negative. Okay, let's see how we get what like terms we have. We have a cubed. Any other a cubes? That's a b cubed. No. Oh, here's an a cubed. So we have a cubed minus 5a cubed. That's going to get us a negative 4a cubed. My next one here is b cubed. Let's look. B cubed. No. I don't have any other b cubes, so I'm just going to go ahead and write that in, minus b cubed. Here we have ab squared. I'm looking for ab squareds. Here's an ab squared. Ooh, this is an a squared b. Ooh. Now, be careful. Those are not like terms. They're not identical. They got to wear the same hats for you to be able to combine like terms. So I'm only combining these here because they're ab squareds. I had 3 minus 2. That's plus 1. ab squared. Now the last thing I need to take care of is these a squared b's. There's no other like terms for those, so I just write in minus 3a squared b. Good. On that problem, the only tricky part is to remember that these are not like terms. ab squared is not a like term with a squared b, so you write them separately. Okay, great. If I take this 5 in, I get 5 times x, which is 5x, plus 5 times 5, which is 25. So that for that first one, we get that answer. I'm going to change my color here. On this next one, again, we would multiply the 3 into everything inside. 3 times 5x is 15x. 3 times negative 7y is negative 21y. And 3 times 15 comes out, 3 times 5 comes out to be 15. So that was the distribution law, which is what we called it. So in today's lesson, we're going to be just doing the same exact thing, except I like to call it super distribution. There's going to be 2 things we need to go in and distribute. So let's take a look at this. Here we have 2 values, and both of these are going to get to these other values. So I'm going to take the x times the x. X times x is x squared, and x times the negative 5, which is minus 5x, and 2 times x, which is 2x, and then 2 times the negative 5, which is negative 10. Again, we're just taking this value and making sure it gets distributed to everything here, and then taking this value and making sure it gets distributed to everything in the other parenthesis. So we're almost done here. Basically, all we got to do now is combine the like terms. We have negative 5x plus 2x. That comes out to be negative 3x. And so our final answer is there, x squared minus 3x minus 10. Now, some of you, back in your previous math days, may have learned the four-letter F word to do these problems. I have a hard time writing it up, but don't get mad if I write up the four-letter F word there. Some of you may have learned this method to do these problems. I'd encourage you not to think of it using the FOIL. Oh, I said it. The F word there. Just because it kind of teaches, it's a limited view of understanding this. If we think of it as distribution, super distribution, we'll do much better. So let me go ahead and do another example here. Let's say that we had x plus 4, and I wanted to multiply that into x squared plus 3x minus 5. Okay, so notice that this is a binomial times a trinomial. Again, we're just going to use the idea of super distribution. In other words, I'm going to take this value right here, this x, and work on distributing it into all the values of the other parentheses. X times x squared, that's x cubed, because we add the powers. And then this times this, x times 3x is plus 3x squared. And x times a negative 5 is minus 5x. Okay, sweet. So I took this first value and I distributed it into all the values in the parentheses. Okay, now I'm going to do the other value here. I'm going to take the 4 and I'm going to distribute. So 4 times x squared, that's plus 4x squared. And then this times this comes out to be plus 12x. And this times this is minus 20. Our last step then is just to simply combine the like terms. X cubes, no other x cubes, so I'm just going to write it, x cubed. X squareds, here's 3x squared and 4x squared. That's 7x squared. Negative 5x and plus 12x, that's plus 7x. And then what about just the numbers? This is the only number available, minus 20. So again, we use super distribution to answer these questions. To the boards! Okay, so it's your turn to apply this super distribution. I've gone ahead and put up here 4 questions for you to try out. Again, you're just going to do super distribution like we've been talking about. Go ahead and pause the video now and give these 4 problems a try. Then push the play button when you're ready to check your answer. Good luck. Okay, here we go. Let's do it. We're going to go ahead and use the super distribution laws. So I'm going to take this 2x and I'm going to every value inside the parentheses. Every single one is my goal. So 2x times 5x squared, that becomes 10x cubed. 2x times an x comes out to be 2x squared. And 2x times a negative 3 is minus 6x. That's the first one. Okay, good. Here we have a super distribution. We're going to take the x and times it to everything inside. So x times x is x squared. And x times negative 5 is negative 5x. Now I'm going to move on to the next value. And so 3 times x is 3x. And then 3 times negative 5, which is negative 15. Now this is good, but we're not quite done because there are some common terms. We can add the negative 5x and 3x, so this really simplifies to x squared. Let's see, negative 5x plus 3x, that comes out to be minus 2x, because negative 5 plus 3, minus 15. That's our answer there on that one. How'd you do? Hopefully all right. Okay, let's go ahead and move on to this one. 2x times 3x becomes 6x squared, and 2x times 5 becomes plus 10x. Okay, this time, now I'm moving on to the second term and multiplying it in. 3 times 3x is plus 9x, and 3 times 5 is 15. Whew, hopefully you had a little more room than I did. It's getting a little crunched in here. We're going to go ahead and combine the like terms. 10x plus 9x is 19x. And so that would be my final answer. X squared, 6x squared, plus 19x plus 15. Okay, So again, this is just super distribution. You're taking one of the values in one side of the parentheses and multiplying it into every value inside the other parenthesis. That's what I'm going to do here as well. Although I'm out of room, so I'm going to go ahead and change this just a little. Okay, I cleaned it up just a little here, and we're ready to get going. So again, I'm going to super distribute the 2x. I'm going to start with the 2x first. So 2x times x squared comes out to be 2x cubed, because this is like a 1 for the power. And remember, when you multiply exponents, you add the powers. Okay. Then I'm going to take this one times this one. 2x times 2x is a negative 4x squared. And this one times this one, 2x times 5 is plus 10x. Okay, good. Now my second term. 7 times x squared is 7x squared. 7 times a negative 2x is minus 14x. And 7 times 5 comes out to be plus 35. My last step then is to combine the like terms. I've got cubes. Any other cubes? No. Okay, so I write 2x cubed. Now I'm going to do squareds. Squared and a squared. Negative 4 plus 7 comes out to be a positive 3x squared. Now my x's, I've got a 10x and a minus 14x. You add those together, you get negative 4x, and then your value is plus 35. Okay, those kind of take a long time, but if you're thorough and you spend, have lots of room on a piece of paper, take your time, draw your arrows, make sure every value get in to the other parenthesis. Okay? And you should be good to go. Let's go ahead and look at one more type of problem that's going to be interesting to take a look at. Okay, so look at this beast of a problem. This is a trinomial times a trinomial. And there's going to be one that we will, one on your homework, and also one on the test that we take. So we do want to make sure you've seen one of these. They're kind of beasts of problems because it's going to be taking this term and multiplying it into all of these, and then this term and multiplying it onto all of these, and then this term and multiplying it onto all those. So it is kind of long. You're going to want to make sure to have plenty of room on your paper. These are ones that can take up like a half page. Man, they're brutal. Let's go ahead and take a look. So to do a problem like this, again, we're going to take this term. It's the exact same rules. Nothing changes here. It's just going to take a little longer. 3x squared times 2x squared. Ooh, okay, so I'm going to multiply the numbers, 3 and 2. That's 6x. And remember, when you multiply powers, what do you do with the exponents? You add them. Yeah, you're right. So 6x to the 4th is what we get. Then I take this one times this one. 3x squared times 3x comes out to be 3 times 3 is 9. And it would be x cubed because we add the powers. Then I multiply this to the 7. And we get plus 21x squared. Good. Next part. I'll even change colors here just for fun. We're going to do this 5x. 5x times 2x squared comes out to be 10x to the 3rd because, again, we add the powers. 5x times 3x is 15x squared, and 5x times 7 is 35x. Okay, nice. Now my last step here, again, I'll switch the sign, or switch the color. I've got negative 2. Negative 2 times 2x squared is negative 4x squared. I kind of ran out of room here. This is what I was talking about. Make sure to save yourself plenty of room. And then this times this would be minus 6x. And this times this would be minus 14. Okay, good. So once you get all the multiplication done, then the last step is to combine the like terms. So we'll go ahead and combine our x to the 4th. There is just one of these x to the 4th. What about x cubed? We've got 9 here, 10 here, no others. So that's 19x cubed. Let's look at x squareds. Here we've got 21x squared and 15x squared and a negative 4x squared. If you bust those out, you get 21 and 15, which is 36 minus 4 is 32x squared. Now we do our x's, and we got 35x minus 6x comes to be out 29x, and then our last value, which is just 14. So again, that's a 3 by 3. We took a trinomial times a trinomial. That's as big as we're going to get, but you could do a lot larger. You could do a 4 times a 4. A 4-term polynomial. That wouldn't be fun. But you could do it. So let's go ahead and give you guys just 3 more problems to try, and then that'll be it for this lesson. Okay, so here are the last 3 questions we'd like you to try out. It's got one of these trinomial times a trinomial that we just did that you get to work on, and then 2 more problems just to make sure that you're understanding this idea of superdistribution. Go ahead and pause the video and try those now in your video notebook, and then we will check your answers. Press play to check the answer. Okay, let's take a look. Trinomial times a trinomial. You're going to want to take your time on this. We're going to take this one. I want a different color. Yeah, here we go. This one times this one. Ooh, x cubed times x squared. Again, x cubed times x squared. When we are multiplying multiplying powers, we add the exponents. 3 plus 2, so it comes out to be x to the 5th. So that's x to the 5th. Then this times this, which comes out to be plus 3x to the 4th. Minus this times this, which would be minus 3x cubed. Okay, good so far? Okay, then 3x times x squared comes out to be 3x cubed. Then 3x times 3x, which comes out to be 9x squared. And then 3x minus 3, which is a minus 9x. Okay, good so far? Now just this last term, we got to take this 2 to everything. 2 times x squared is just 2x squared. And 2 times 3x is 6x. And again, the 2 times negative 3 is negative 6. Like every single one of these into the other parentheses. Kind of gets long. And then our last step, of course, is to just combine the like terms. So x to the 5th. Do we have any other x to the 5ths? X to the 4th. Do we have any other x to the 4ths? Nope. X cubes. Oh, here's an x cubed, and here's an x cubed. Oh, that's interesting. We had negative 3x squared, cubed, plus 3x cubed. Those go away. Sweet. Okay. Now, we've got, let's see, we did for the 4ths, we did our cubes, squareds. We got 9x squared and 2x squared. That comes out to be 11x squared. And then negative 9x plus 6x, that's a minus 3x, and then just my numbers. And that's the answer we should have got for that one there. X to the 5th plus 3x to the 4th plus 11x squared minus 3x minus 6. Okay, this one here, this one was pretty easy just to kind of make you feel better after that hard one there. We take x times x, and I get x squared. X times negative 5, which is negative 5x. 5 times x, which is positive 5x, and 5 times a negative 5, which is negative 25. Notice here we have a negative 5x plus 5x. Those cancel out, and so our final answer is x squared minus 25. Okay, and on number 7, it was just kind of a test to make sure you knew how to multiply your exponents here. X squared times x to the 4th, you add the powers, we get x to the 6th. X squared times 5 is 5x squared. 3 times x to the 4th is 3x to the 4th. And 3 times 5 is plus 15. Are there any like terms to add here? 6's, no. Squareds, no. 4. So there's no like terms to add. It should be known that if you looked at this and like you were doing this as a test question, this answer probably would not be there because they would have it in descending order. It's usually good to put it in descending order. X to the 6th plus 3x to the 4th, because we do powers. The highest powers come first. Then put your 5x squared plus 15. The answers are really the same, but just know that usually we like to write these in descending order.
Throughout this entire video, when we multiply polynomials, we've been calling it super distributing, which is really descriptive of what it is. Because of these plus signs in here, you must distribute, and you've seen this before, but I wanted to show you this one more time. Let's distribute this out and see what we get. When the 2x goes through, we get, and when the 5 goes through, we get, And if we pause here for just a moment before we combine all the like terms, notice that we took a binomial, 2 terms, times a trinomial, 3 terms, and before simplifying it, we ended up with 1, 2, 3, 4, 5, 6. 6 terms. 2 times 3 is 6, and end up with the 6x cubed plus 19x squared minus 4x minus 35. So that really, the blue went in and gave us the blue, the red went in, gave us the red, and you can see that the binomial times the trinomial gave us 6 terms. Now, some of you may have heard of the acronym FOIL and have been wondering, why haven't they said, why don't you FOIL it all out? Well, technically, FOIL comes from when you take a binomial times another binomial. This is a 2 times 2, which gives us 4 terms. And when you super distribute, you get the 2x squared. And those were of a binomial and a binomial, the front 2 terms times together. So that's where we get front. That reminds you that you times the 2 front together. Then when you super distribute the 2x over there, and you get minus 10x, and then of course we do the 3 in, get a plus 3x and a minus 15. We did the front 2 and then the outer 2, this 2x and this minus 5 are the outer ones, and the inner 2, the 3 and the x right there, and then the 3 and the negative 5. Now the reason why FOIL is not necessarily like really a math algorithm, a process, is that it's simply an acronym that helps you to remember to do all 4 of these terms. But notice how it doesn't apply over here. This is the concept. This is the one that stays true no matter what. Anytime you have polynomials or plus signs in what you're timesing, then you super distribute. This is an acronym that is really only applicable when you have a binomial times a binomial, 2 times 2, to get 4 terms, and then you'll combine those middle terms. But that's how FOIL came about and is in the vernacular of many people, and usually isn't valuable at all, especially unless you are in a binomial times a binomial. There is one particular location in life when it is very valuable to remember, hey, you have to super distribute or FOIL it out if that's the case. If you have something like 2x plus 3y and it's a perfect square of a trinomial, you have to watch out because you may not take this exponent and go 4x squared plus 9y squared. This plus sign just ruined that entire plan. Remember, squared means you take this times itself, 2x plus 3y. Notice these plus signs require that super distribution. So you get 4x squared plus 6 times x times y, then plus 6 times x times y, plus 9y squared. Again, I'll do this in red so it burns itself into your psyche. If you do this and say, oh, that must be 4x squared plus 9y squared, you have just committed a cardinal sin. This is actually, it's been around for hundreds of years that people have tried to go around this plus sign and the required distributing, and it is called the freshman's dream. In other words, freshmen wish they would be able to do that and make life so much easier, but that is not the case. And upperclassmen for the past 1,200 years are rolling over in their graves because they committed that same mistake. So if there's a plus sign, you may not carry that in there. If it's all multiplication, it's safe. But if there's a plus sign, you must do this distribution. And we end up with 4x squared plus 12xy plus 9y squared. And there will be opportunity in your homework to make sure you get that. But that's the one time when people do this, they have forgotten to FOIL, which is just an acronym for distributing appropriately. Hopefully those little caveats will help you in your journey.